Century saw a digital age powered by classical bits, transistors, and silicon chips. Now, in the 21st century, we are stepping into the quantum age where the rules are stranger, the possibilities are greater, and the stakes higher. Yes, you heard the right thing. Today, I am truly excited and honored to share you with the fascinating concept of quantum age, an era that is not only changing the way we understand our universe, it is reshaping our technology, our economy, and the very fabric of our daily lives. So, what exactly is quantum age? Simply put, it marks the dawn of a new technological and scientific frontier based on the principles of quantum mechanics. Quantum mechanics is a branch of physics that deals with the study of matter and energy at the smallest scales, like at atomic and subatomic levels. While classical physics deals with much of what we see, quantum physics reveals a world far more stranger, powerful, and beyond our imagination. Quantum mechanics is already at play in everyday technologies, from your smartphone's GPS to the MRI machines in the hospitals. It is available everywhere. Sir Max Planck is referred as the father of quantum physics. He introduced the theory of quantum to the world in the year 1900. Other great scientists such as Albert Einstein, Niels Bohr also contributed significantly to the development of quantum physics. We should always remain grateful for them. The foundation of this era lies in harnessing unique quantum properties such as superposition and entanglement. These are used to create technologies that were once thought impossible. Now, let us dive into some of the potentials of quantum age. First, quantum computing. Unlike the classical computers which we use every day, which rely on bits that are either 0 or 1, quantum computers use qubits. Qubits can exist in 0, 1, or in both of them simultaneously. This allows them to process on a massive number of possibilities at once. This property is known as superposition. But now you may think, why does it matter? It matters, my friends, because it allows quantum computers to solve certain problems exponentially faster than today's supercomputers. Imagine cracking codes, optimizing supply chains, and initializing molecular interaction that today's computers will take thousands of years to do. Quantum computers can do them in minutes. Second, quantum communication. Another remarkable leap in the field of communication is through quantum entanglement. It is a property in which when two particles are linked together, the change in the state of first particle will instantly affect the other no matter the distance between them. This will be used to create ultra secure communication channels. This would revolutionize cybersecurity for banks, governments, and everyday users. Third, economic growth. Other industries such as artificial intelligence, defense, finance, education, logistics, and many more will get huge economic boost because of quantum problem solving. But my friends, with great potentials come significant challenges. And of course, this era hasn't come without any hurdles. Quantum systems are incredibly delicate. The properties which give it strength also make it very unstable. Slight disturbances like heat or vibration can disrupt them, a property known as decoherence. They also require advanced cooling infrastructure that reach temperatures near to absolute zero, making them very expensive to build and maintain. Another hurdle in front of us is the lack of skilled workforce. For the same, we must include more and more skill-based programs in our education so that we can have more professionals who can work upon quantum age. In conclusion, I would like to tell you all my opinion about the future of quantum age. The future of quantum age will provide us with extraordinary possibilities, from solving advanced scientific puzzles to drug discovery. But it will also be a challenge for us to be wise, ethical, and inclusive about how we develop and deploy this power. All that I told you is just a tip of the iceberg. If you take the topic quantum mechanics, even a day will not be sufficient to tell me all about it. Before leaving this podium, I would like to tell you all one interesting thing about quantum technology. Scientists today have discovered a method to convert iron into gold by changing the electronic configuration by using quantum technology. Though today it is only possible theoretically, but I believe that in the near future, scientists will develop a technology so that they can change iron into gold and then any other useful material practically too. That's all from my side. Thank you and have a spectacular day ahead. Jai Hind, Jai Bharat.
So you are just talking about the future related with the quantum mechanics, changing the configuration of electrons.
Yes.
So whenever that ferrous and iron is going to change into gold,
Good.
similarly it can be possible that the radioactive substance and their activities related with the energy creation. So I'm not going to destroy energy creation. That's a nuclear
Atomic bombs.
I'm not nuclear reactors,
Mhm.
not at the atomic bomb. I'm not discussing about. I'm talking about the nuclear reactors.
Yes.
Simply that the atomic configuration of any other element can be enhanced the electronic configuration towards that the uranium or maybe can be changed that the plutonium to give more type of energy.
Yes, sir, it is possible. But today, scientists have developed a method so that they can theoretically do it. Because if we think of practically doing it, there are many barriers like expensive materials and the lack of that type of knowledge. But I think that in near future, if we at now presently it is just started. In the near future, when scientists will study more about the subatomic particles, I believe that in the near future they will find a method so that they can turn uranium, plutonium, in any other useful material which we want. Sir.
So quantum mechanics nowadays, is it economically feasible to us or not? Okay, there are so many discussions here and around that. But when you are talking about that the elementary creations, elements changing the configurations. So in near futures, how we can you can say that it will be fruitful to us because that from last generation, last many generations, any society in the world, gold they take as a economical balance with them. Okay. So when you are changing the configuration of a regular material or regular elements, it is not going to be the economical viability in the society.
Sir, it will be, but we are not thinking about converting all the iron into gold. We have just found one example that yes, we can turn iron into gold. We are not going to do it. When it necessary, we will do it. But we will try to convert other materials such as carbon into some other useful material and all that. And yes, it will hamper economic balance, but in the future we will find some way because if there is a will, there is a way. We can find a way to this.
And what that first I asked question, I will ask you also that these kinds of technology can we can use to reduce spoilage in the society or between the nations that attract towards the fight or wars.
Yes, we can, in case, because this is a new technology and this would lead to a lot of competition. So there will be a chance of fight between nations, but if all the nations sit together, think upon it, then there will be no fight among and the stronger nations are already ahead. If they support the poor nations and take everybody along with them, then there are no chances of fight among the nations. And if talking about society, then we know that if one person is educated or who knows about quantum age, he will automatically educate the others who are beside him. And we are also trying to inculcate quantum age or quantum mechanics in everyday education from 6th class, 7th class onwards, so that the future generation of India will have a basic idea about what is this, and so that we can have in future we can have professionals who can work upon it.